Hello, ladies and gentlemen. I hope you are all doing well. Root Beer here. We're going to be finishing up our 2011 open paper. What a fine paper it's been so far. We're going to be looking at question C4, last question, in theory the hardest question on the contest. If you haven't taken a look at it, I would really recommend you give it a try ahead of time, but let's dive in and see what we can see. Let's see if we can figure this one out. Okay? So what have we got? Let f of x equal x squared minus ax plus b. A and b are positive integers. All right. So we've got two parts here. Even if we can just do a part, that would be fantastic. Suppose a is 2 and b is 2. Determine the set of real roots of f of x minus x and the set of real roots of f of x minus x. So f of x should be a quadratic. Okay. So f of x minus x is not going to be that bad. Because it's going to be what? X squared minus ax plus, it was plus b, right? I'm already forgetting the question. Yeah, plus b. And we even know that a and b are 2. So it's x squared minus 3x plus 2. It is not that difficult to factor this. It'll be x minus 2, x minus 1. So the roots are x equals 1 or 2. Okay? And that could even be worth a mark, maybe even 2 marks. Now f of x minus x. So that's going to be, let's see, we'll have x squared minus a, which in this case is 2x, plus 2, and then it'll all be minus x. And what goes in place, where we should have an x, we put our original function, 2x plus 2, x squared minus 2x plus 2. Let's expand this out. So we'll have x to the 4 minus 2x cubed plus 2x squared minus 2x cubed plus 4x squared minus 4x plus 2x squared minus 4x plus 2, plus 4. So that's just expanding the first one out. Minus 2x squared plus 4x minus 4 plus 2 minus x. So it's up to me to start cleaning this up. Only one x to the 4 available. X cubed, there's only going to be the 2 of them, so 4x cubed. Crossing things out as we read them across is a good idea. Plus 2 plus 4, so that's 6. 8 minus 2, so that's plus 6x squared. And then minus 4x minus, so that's minus 8x plus another 4, so that's just going to be minus 4x. 4 minus 4 plus, oh sorry, no, I forgot another 2. So 4 minus 4 plus 2 is going to be a plus 2. But I forgot a minus x at the end there, so this is actually minus 5x. Okay. And you might say to yourself, yikes, a quadratic, where do I go from here? Well, first this might start spurring us on ideas on how to handle the B part, because usually when you see a more difficult, especially a C part question, if it's broken up into A's and B's, they're actually trying to ease you into the problem. So they're trying to be nice. So we might start exploring how to deal with things like this, because if we look ahead, I don't know exactly because I didn't read it, but I did see a f of x. Yeah. So B part, determine the number of pairs of positive integers a, b for which every root of f of x minus x is an integer. So we might really want to start devoting, well, how do you solve roots of f of x? Right, now I know what B part is. I only caught it out of the corner of my eye earlier. But, well, this is tricky, but we could always make a guess. One thing that sort of strikes me when I'm confronted with a quadratic or a cubic or a quintic, I do try some silly, obvious things like, is 0 a root? And the way you check that is there no coefficient, no constant. Other things to check, 1 is pretty easy to check. Just look at the coefficients of all the numbers. If they add up to 0, then 1 is a root. And 1 minus 4, so minus 4 and minus 5 is negative 9. 1, 6, and 2 is 9. So 1 is a root. But I'm willing to bet 2 is also a root. And let me explain my reasoning just before we move on. So if I've got f of x minus... if r is a root... Because we do need to explain our work for a question like this. We've got to be careful. If r is a root of f of x minus x equals 0, then f of x is equal to... then f of r is equal to r. F of r minus r is equal to 0, and that means f of r is equal to r. Okay? So that's kind of nifty, but then f of x minus r, minus x has a root of r. Right? Why? Well, f of r minus r is equal to... Well, what's f of r? We know f of r is r. So we get f of r minus r. But f of r is r, so we get r minus r, which is 0. So any roots of this expression are also roots of this expression. I don't know if it goes vice versa. I don't think so. But this tells me 1 and 2 are roots of x to the 4 minus 4x cubed plus 6x squared minus 5x plus 2. Okay? And I want to find those roots, so that's fantastic. And that tells me some of the roots. Does it tell me all of them? Well, no. So what I'm going to do now is I'm going to... this tells us that... what can we say here? Well, I think this tells us that f of x minus x as a polynomial is a factor of f of x minus x. I'm a little worried about a statement like this. Kind of awkward, but I'll put a pin in this. I can definitely do long division, polynomial long division with what we've got here. Divide through, so how many x squareds go into x to the 4? X squared of them. So we got minus x cubed plus 4x squared minus 5x. Minus x's go into that. So we got x squared minus 3x plus 2, and exactly one of those go in there. And so, does this have any roots? X squared minus x plus 1? I can't think of anything off the top of my head. I think it has no roots. Quick quadratic formula, the b squared minus 4ac. No roots. X squared minus x plus 1 has no real roots. Therefore, x equals 1 and 2 are the only roots of f of x minus x. Great, so now we've managed to figure out A, but by looking at B, we can start to get a sense of what we might try and do. So I want to reread B just to be clear. Determine the number of pairs of positive integers a, b, with a and b between 1 and 2011, for which every root of f of x minus x is an integer. Now, do they not count complex roots? I feel, f of x is a quadratic, so f of x is a quartic. And so, using some more general or advanced math, you know that a quartic has 4 roots, but some of them might be complex numbers, just like a quadratic always has 2 roots, but some of them might be complex numbers. The problem is, what is the state of high school education? Do they leave complex numbers out and just say something like x squared minus x plus 1 has no roots? Or do they say those are the real roots and the others are complex, but we don't talk about them? Because I'm pretty sure, I've asked some of my students, and we don't really talk about complex numbers anymore in Ontario, which makes me sad. But, I don't know. Puzzling. Incidentally, leave me a comment down below to tell me the state of the current Ontario curriculum, or really any Canadian province curriculum, so that I'm kept up to date. Do you think they're talking about complex numbers? I'm going to assume that they are allowing complex roots, and that we specifically want integers. We want 4 integers. And if that's the case, this is going to, I think, get more fun. Okay. So I'm going to try and put it together the way that we just did it. So we know f of x minus x is going to divide f of x, I think. And so we definitely want f of x minus x to have roots. Yeah, definitely. And I think we're going to have to play around with polynomial division. So f of x is equal to x squared minus ax plus b. F of x minus x is going to be x squared minus a plus 1 x plus b. And I foresee that becoming annoying to write out. Now, f of x. I don't want to have to write this out too many times, but let's at least see it once, just so we can get a handle on it. Okay. So we will have x to the 4 minus 2ax cubed. I'm just going a little faster here, that's all. Plus, there'll be 2b's plus a squared x squared. Minus 2abx plus b squared. Minus ax squared plus a squared x minus ab plus b. Alright, so that's what I'm looking at. I suppose we could clean it up a little bit. Uh, 2b plus a squared minus a. And with something like this, I might also be tempted to check my arithmetic, but I don't think that will be necessary. I'm going to factor the end here. B, and then it's b plus 1 minus a. Okay, so I think that's good, and then f of x minus f of x minus x should be the same thing, but we switch one of them out. anyways, the reason I'm not going to double check this work is because I'm going to long divide this now by f of x minus x, and it should work out. And if it doesn't, then I'll think that, okay, either my theory here is wrong, which I don't think it is. I think it should work even in the abstract. Or I've made a multiplication error here, and that will give me a chance to go and double check. But if something I'm going to do is already going to check my arithmetic for me, why bother to check my arithmetic right now? So minus a plus b, or a plus 1x plus b, x to the 4, oh gosh, I can't even remember what it was, minus 2ax cubed. The end being factored as b plus 1 minus a, I think is going to be kind of nice, because then it really should tell me that I get a b plus 1 minus a up here. Okay, 2b... So 2b or 2b squared? 2b plus a squared minus a x squared, and then a squared minus 2ab plus 1 x plus 1? No, minus 1. Minus 1. Okay, and we should also start with an x squared here. So multiplying through x to the 4 minus a plus 1 x cubed plus bx squared. Alright, doesn't seem that bad. A minus 1, no, 1 minus a. 1 minus a. So then it should, in theory, be 1 minus a x up here. And then subtracting a b from there, we get plus b plus a squared minus a x squared. We bring this one down here. A squared minus 2ab minus 1x. Okay. Out of curiosity, if that's a and that's b, we should get minus 1x plus 1, which we did. We did do that before. Okay. So 1 minus a x cubed here. Those will cancel out quite nicely. Plus 1 minus a, 1 plus a, that's a squared minus 1. But is it plus or is it minus? Negative a, negative a. Okay, yeah, we're good. And then b minus ab x. Alright, that cancels out. A squareds will cancel out. And so we'll be left with b minus a plus 1 x squared. Or let's write it the way I had it before. B plus 1 minus a. And then hopefully we can factor out an a here. Or an a plus 1. We will get a squared, nothing to cancel with that. Minus 2ab minus 2ab is a minus ab. Minus 1 gets left alone, and a minus b stays here. X, and then we bring this down, b plus 1 minus a. But if I just look at this part, I can take factor of it's a 1 a minus b, a minus b. Wait a minute, what? What would be, let's use green, what would be a plus 1 times b plus 1 minus a? Well, what if I multiplied those together? So b times minus a would be minus ab. B times minus 1 would be minus b. 1 times minus a would be minus a. 1 times minus 1 would be minus 1. Negative a times negative a would be an a squared. Negative a times negative 1 would be a plus a. Those cancel out, and I do get what's left here. So, okay, it factors properly. Okay, so f of f of x minus x is equal to f of x minus x times, and I don't think there's a good way to write this out. Well, actually, let's just get them all quadratic, shall we? X squared minus a plus 1x plus b, and then x squared plus b minus a plus 1, I think. Yes. And then 1 minus a. Okay, so I need there to only be integer roots to these two expressions. And I should probably write that down in case I run out of time on the contest. Explain to them that I understand what's going on here. Need only integer roots. Okay. So, what do the roots of that first expression look like? So, here's where the quadratic formula will come in handy. Negative b. Incidentally, the b here is negative a plus 1. It's going to be confusing because I'm going to have a's and b's lying around, but square root of, and it'll all be over 2, so I'll definitely need to ensure that the top is odd or something like that. But b squared minus 4a, which is 1, c, which is b. Alright. So I need those to be integers. That's interesting. So I need a squared plus 2a plus 1 minus 4b needs to be an odd square. Odd square? No, not necessarily. See, I don't know what a plus 1 is. If a plus 1 is even, I need this to be an even square. If a plus 1 is odd, I need this to be an odd square. But I think it will be fine. A plus 1 and a plus 1 squared have the same parity, oddness and evenness. And so does a plus 1 squared minus 4b, because it changes by an even number, so if it was even, it was even. The end result is even. If it was odd, and subtracting even gives me an odd. And so will k equal to the square root of a plus 1 squared minus 4b, assuming it's an integer. So to get roots, to get integer roots, of x squared minus a plus 1x plus b, we need only have k be an integer. So this gives me some conditions. No matter what a I choose, if I add 1 and square it, the b needs to make it so that minus 4b is also a square. So that's kind of interesting. Okay. And we've got 2 plus 1 squared would be 9, minus 2 times 4, so minus 8 is 1, and that would work for the 2 and 2 case from part A. However, we also need the other one to have roots. So for x squared plus 1 minus a x plus b minus a plus 1, I'm pretty sure that was it. Let me just double check. B minus a plus 1. So it's going to have roots of negative b plus or minus square root of b squared minus 4 AC. That's a little different, a little trickier. All divided by 2. But again, it's just going to come down to, so similarly, I'm going to call this T, I guess. A minus 1 squared minus 4b minus a plus 1. If this is odd, subtracting by an even will make the square of t odd. So these guys have same parity. If t is an integer. So we just need t to be an integer. Okay, so to summarize, to get only integer roots, a plus 1 squared minus 4b and a minus 1 squared minus 4b plus 4a minus 4. I'm pretty sure I got that right. Must be perfect squares. Alright, so that's good. Now I just need to sort of solve these. Okay, I don't know as I can necessarily think of a way to do that, but let's see here. Let's call one of them k squared, one of them t squared. Now k squared minus t squared is going to be a squared plus 2a plus 1 minus 4b. Subtract a squared minus 2a plus 1 minus 4b plus 4a minus 4. The 4b's will cancel out, and that I think is important because now we're not talking about b. I think that's important. The a's will cancel out, the 1's will cancel out. We'll be left with 2a minus negative 2a, so that's going to be 4a, and minus another 4a, minus 1. Or sorry, minus 1, so that's plus 1. But 4a minus 4a plus 4 is equal to 4. So that's, I mean, I thought I was just going to get rid of the b's, but I've actually gotten rid of the a's as well, so I need to... I need two integer squares. That are 4 apart. And I've spelled apart wrong in my haste. Okay, so I would say it's clear that 0 and 4 are my only options, but let's be more precise about this. So k and t are integers. So k minus t, they've got to be factors. So we could have negative 4, negative 1. We could have negative 2, negative 2. And what would be the k and t, by the way, here? We could have negative 1, negative 4. We could have 1 and 4, 2 and 2, 4 and 1. Just cramming them in there. And how do I figure out my k and my t? You add k minus t. This comes up every once in a while, so it's a thing I sort of know how to do. K minus t plus k plus t is going to, the t's will cancel out. You'll just have 2k divided by 2. You'll get k. Do the same sort of thing, but take the difference, and you'll get your t's. But this would be minus 5 over 2. That's not an integer k. Minus 2 plus minus 2 is going to be negative 4 divided by 2. K is negative 2. That's a possibility. And then what would the t be? T would be 0. And we could have another negative 5 over 2, so that's not going to work out. Or we could have 5 over 2, not going to work out. Or we could have 2, and then again t is 0. or you can have 5 over 2. So t equals 0, k is 2 or negative 2. Now let's work this out. I'm going to say the t equals 0 is pretty important. Because this tells me what? A minus 1 squared minus 4b plus 4a minus 4 is equal to 0. And then, oh, I just realized that these two combine to make a plus 1, or a plus 1 squared. Okay, but a plus 1 squared minus 4b is exactly what k squared is. So maybe this isn't the right thing to do, but okay. A plus 1 squared minus 4b is equal to 4. Right? So that's what we've got. So that's a nice relationship. A plus 1 squared is going to be 4b plus 1. So a plus 1 is even. Okay, it's even, and then, yeah, it's not bad. Now, are we trying to find all pairs A and B, or are we just trying to find the number of pairs? So there could be a lot, and we just have to learn how to count them. So a plus 1 squared minus 4b is equal to 4. That's sort of our defining condition. So we need a can be odd, and then let's say a is equal to, I don't know, 2c plus 1, right? So then a plus 1 is 2c plus 2. A plus 1 squared is going to be, well, pull out the 2. So 2 squared, c plus 1 squared. So that's going to be 4c plus 1 squared. C squared plus 2c plus 1. But this needs to be equal to 4b plus 1. Divide by 4 on both sides. B is going to be c squared plus 2c. Okay. So I figure if we count up the number of c's that work, we'll be all set. Now, A is between 1 and 2011. So C plus 1 is between 1 and 2011. So C is between 0 and, 2C plus 1. So 2C is between 0 and 2010. Divide by 2. C is between 0 and 2005. So this could be 1006 possible C's, but there's also the B's, and I think B is a bit more strict. So 1 is less than C squared plus 2C. I think it's probably easiest just to add 1. So 2 less than or equal to C squared plus 2C plus 1. 2012. So C plus 1 is a square between 2 and 2012. So it's at least 4. And what's the biggest square near 2012? Well, I know 2045 is something. No, 2025. Is 45 squared. So C squared is at most 44 squared. So you can't go over. So that tells me C plus 1 is between 2 and 44. And so C is between 1 and 43. So that severely restricts things, and there's 43 possible C in this range. So I'm finishing off the question. I'm going to say 43 possible values, possible pairs, A and B. Now, of course, it's my video, so I've got a little extra time. I suspect if you were doing this, you might be running out of time. I'm pretty confident in the 43, but if you've got the time, you might do what I'm about to do, which is just sort of spot check one of these C's, right? What are the possible C values? Well, they're between 1 and 43. So what if I just took C as 1 or C as 2? Okay, so this is just some little side work. If C is 1, did all the math work out? So what is A? It's 2C plus 1. So A would be 3. And what would B be? So 2C plus 1 is 3. B is C squared plus 2C. So that's 1 squared plus... So B is 3 as well. So we're looking at x squared minus 3x plus 3. Does this have... it's not this one. It's x squared minus 4x plus 3. And this has integer solutions. 1 and 3. But what about the other one? So 1 minus a, b minus a plus 1. Okay. Can I even find roots for these things in terms of a and b if I know they're going to factor? In a nice way. I'm not entirely sure. So we'd have plus 1 minus 3. And then 3 minus 3 is going to be 0 plus 1. So x squared minus 2x plus 1. Bingo. It worked out. That has integer roots. What if we tried something like C is, I don't know, 4? Well, 2 times 4 plus 1, a is going to be 9. This might be too much for me to handle. 4 squared plus 8 is going to be 16. So b is going to be 24. So x squared minus 10x plus 24 would be my x squared minus a plus 1 x plus b. And does this have, x minus 4, x minus 6. And what about the other one? If a is 24, we're going to look at 1 minus 9. And then 24 plus 1 is 25, minus 9 is 16. So of x squared minus 8x plus 16, and this also has roots. It's going to be x minus 4 all squared. Does this always happen? Actually, let's just quickly let's check. The question's long over. I'm just investigating things now. So we'd have, what are our two quadratic polynomials? A plus 1, and then b is c squared plus 2c. So that's x squared minus 2c minus plus 2 times x, and then c squared plus 2c. So I could pull out a c plus 2, yeah. So it's x minus c, x minus c plus 2. Right? So if I had c is 4, yeah, x minus c and x minus c plus 2. And then what's the other one? Well, it's plus 1 minus a, so 1 minus 2c plus 1, x. And then b minus a plus 1. Yeah. So that'll be x squared minus 2c, because the 1s will cancel out, so minus 2cx. The 2c's will cancel out. The minus 1 and the plus 1 will cancel out, so plus c squared, and that's always x minus c squared. Well, that's kind of nifty. I now know what the roots are going to be. There's going to be 3 c roots and then 1 c plus 2. All right. I like that. I could go a little further with that. I always like going a little further with questions. But there we go. So we have finished our 2011 open paper. This was the first open paper in the new format. Nice, neat, interesting. I like the booklets. I always like saying I like the booklets. Up next would be the 2012. If you're looking for similar contests, of course, Waterloo's intermediate and senior math contests are similarly themed. They are what Waterloo used to replace the Open after the big schism. So you can look at those for more difficulty, or any other any other contests that make you practice your written skills and things like that are always good. Always be trying more contests. You always learn new things when you try a new problem out. Okay, but that's going to be it for me. So thank you guys so much for watching. If you like the open paper and want to see more of them, feel free to leave a like or a comment or any sort of thing like that. And have yourself a wonderful day.